This is the second part of my video on LED panels, Inrush and dimming. In this one, we're going to concentrate on dimming LED panels. Domestically, it's generally phase cutting dimming, mains voltage dimming, our little dimmer module in the switch, the wall switch. That's actually chopping out bits of the sine wave. Two basic types, leading edge and trailing edge. The leading edge cuts off the beginning of the sine wave. Trailing edge cuts off the trailing edge of the sine wave. LEDs seem to prefer having the trailing edge cut because you've got a smoother initial startup. And so domestically you've often got some phase cut sine wave put onto the driver, which is then converted into DC and goes onto a fitting. Or that phase cut sine wave could go directly to a bulb. We're getting some decent results with that now. In your larger installs, you'll have more sophisticated and expensive control gear. You'll have some digital or analog dimming. You'll take a mains voltage to the driver, but the actual signal, the dimming signal, will be some digital protocol, and that sends a signal to the driver which controls the brightness of the lights. This is also better for inrush current because we're not switching a mains voltage current. Most LED panels don't seem to like mains dimming. You'll have the basic push type dimming, and even then with push dimming you need a live and neutral and the push signal. You get lots of different types of drivers. I suppose the basic two are constant current and constant voltage, and they do what they say. A constant current driver, it's going to deliver that constant current. LEDs are quite fussy, they like a particular current. If they get too much current, they'll get very bright and they just won't last as long. If they don't get enough current, they might not work at all. Generally used in your higher output LEDs. LED panel drivers are probably constant current. Constant voltages are when you need a constant voltage. The common ones are 12 volt and 24 volt. They're often used for LED tape. The 24 volt generally give you more light output. When you're buying panels, you can specify the type of driver that you want. You often have to ask for a dimmable driver. They generally come with a non-dimmable driver. Dimming is often not a common feature, so you have to specify what you want to be able to do. Sometimes it depends on how it's wired as well, what driver you need. You have your series circuit and you have your parallel circuit. In a series circuit, current is constant. In a parallel circuit, voltage is constant. PVC. That's how I remembered it. Remember one, you remember the other one. And just because you've got a constant current driver doesn't mean it's in series. The mains input could be in parallel. Most LED lights have their own individual driver. So let's have a look at push dimming and 1 to 10 volt dimming. Let's see what's actually involved with that. So the most important thing to find out is your LED panel dimmable. Most LEDs are dimmable if they've got the correct driver. And when you look at the driver, it'll tell you what your dimming options are. In this example here, this driver can be dimmed by push dimming, by DALI, or by 1 to 10 volt dimming. Sometimes it says mains dimming. Push dimming is mains dimming. This driver's datasheet said it was mains dimmable. It can be dimmed from a 230 volt source. This is where you need to confirm with the manufacturer what they mean by mains dimming. It'll push dim, but it won't accept triac dimming. So we need to check the compatibility of the dimmer, the driver, and the lamp. 1 to 10 volt and push dimming are one of the most basic and simple types of dimming method you can get for these LED panels. DALI and such, more complex. If you don't get all the components right, you're going to get flickering. You're not going to get smooth dimming performance. You'll get like a surge flash when you switch on. And the most worrying thing is, if you've got the wrong type of dimmer, the components in the module will start to overheat. The basic principle of 1 to 10 volt dimming is that the dimmer module sends an extra low voltage signal to the driver. So dimming is controlled by how much voltage the driver receives from the module. It's got a range from 1 to 10 volts. 1 volt, the driver will dim the light down to its lowest level, and 10 volt will bring the brightness to 100%. Now this particular module drawn here got two functions. Pressing the spindle will connect common to L1 and send a 230 volt output to the 230 volt input of the driver and turn the light on or off. Rotating the spindle will send a 1 to 10 volt signal to the driver to control the brightness of the light. These are the connections. We have our circuit protected device, a B10 RCBO in this case. Power will leave that and go to common on the dimmer module. And the switched output L1 will go to the 230 volt connection in the driver. We need a neutral, of course. Then the control side, the positive goes to positive in the driver and the negative goes to the negative. 1 to 10 volt dimming is polarity sensitive. Very simple wiring and control. And you get nice smooth dimming. You also get 0 to 10 volt dimming as well. They're very similar, but they are two different standards. They're both analog control. Analog means the constant signal that you can change. It could be a constant 5 volt signal, keeping the lamp at about 50% of brightness. The main difference between the two standards is the direction of current between the dimmers and drivers. It does have its downsides. You don't get any intelligent control, RGB and such. It's not addressable. It doesn't communicate with you. There's no standardized dimming curve, so compatibility with other 1 to 10 modules, drivers, lights may not give you the dimming performance that you want. 0 to 10 volts, you can actually switch the lamp off with the signal voltage. 1 to 10 volt, you need some kind of switch or relay to turn the lamp off. But it's a pretty robust system which has been around for a long time and it's quite simple to install really. Here's a little video. These are the connections that go to the actual lamp. They're your 0 and 10 volt connections. This is the dip switch so you can set the milliamp output. They're the DALI connections. These are your main voltage connections. You've got your push, you've got your neutral and your live in. This is all isolated, there's no power on here. Just common my neutrals together. A lot of these are class 2, but you need to run a CPC to every point. I've also commonly live connections, so I've only got one connection in the back of the dimmer. Here you can see the connections. You've got the 1 to 10 volt connections at the top there. You've got your 230 volt connections at the bottom, electrically separated. On the ELV side, you might be tempted to use something like Cat5 or something. It's only 10 volt, but it's all in the same enclosure as 230 volt equipment. The insulation on all your conductors needs to be rated to the highest voltage present. And you can also get interference if you run the ELV side along the mains voltage side, because the dimming performance is totally reliant on the voltage it receives from the module. And if you've got mains voltage cable running alongside ELV cable, you might get some interference there and cause some problems with your dimming. And this is actually dimming. The camera footage is not the best here, I must admit. It struggled to do with the brightness of the panel. Press of the switch, press of the dimmer, the light comes on, press again, the light goes off. You rotate the spindle to alter the brightness of the lamp. It was quite a nice smooth dimming performance. As for the maximum amount of panels you could have on this module, for example, I contacted the manufacturers. They didn't give me a number of panels. They recommended using a switch on the dimmer to switch a relay rated to the appropriate inrush of the fittings. This module is only rated to 6 amps. Right, we'll move on to push dimming. Push dimming is mains voltage dimming. Most simplest form really, I reckon. You have a retractive switch which you press and that sends a signal onto the driver and then onto the light. You press for on, you press for off, you press and hold to scroll through the dimming performance. You press and hold to scroll back down the dimming performance. It's as simple as that. Push dimming is basically just a switch. There's no electronics like you might have in a dimmer. So we're not doing any phase cutting here. We're not changing the waveform of the AC current coming in. We're just sending a 230 volt pulse. And then the driver deals with the dimming, steps it up or down. Like I say, it's a bit clunky. It's pretty useful. It's certainly not super smooth digital dimming, but if that's not a concern, if you just want to change the settings, not everything is a big office. Could be a church hall or something that just want to have a few panels. So it's a useful and basic type of dimming, which is quite robust. The driver's data sheet says a maximum of 20 drivers controlled by one push switch. Here's the wiring. We have our incoming live, which I've just commented, and a connector. That goes to COM on the retractive switch. We also take a permanent live feed to the driver. And on the make side of the retractive switch, you get make or break. We want to make, don't we? That goes to push on the driver. We need a neutral. And that's it, that's your wiring. When you press the switch, COM and 1 connect together. That'll switch the light on. And if you keep your finger on the switch, it'll either dim up or dim down depending where it is. So DALI stands for Digital Addressable Lighting Interface. Digital means it's a technology that generates, stores and processes data. Basically, it's streams of noughts and ones. It's addressable, which means it has two-way communication, which allows control and communication between any component of a system. And it's a lighting control system. It's not a building management system like KNX or such. It's an interface. It's the interaction between the technology of the system and a person. And it's kind of simple and it's kind of complicated. This is one manual from Tridonic, which I pulled off the web, and this manual's 169 pages long. It is basically quite simple, but because this can be managing a massive building, it can become quite complex as well. Pretty much like that 1 to 10 volt lighting, except this is addressable and you've got a lot more control. We're not using mains voltage for dimming. Mains voltage is taking the drivers and such, but the control is on a bus. It's 16 volt control communication, so the wiring is quite simple. You have some kind of control system, some software, and that can also go through a network hub as well, so you have like remote wireless connectivity to the various components. Then you have your bus power, which is a two-wired two-way communication, and that can just go around the building and you can tap into it with the driver or with a switch or with a sensor in any configuration. Every single component has a unique address, so you can tell one light to change colour, one light could be switched by a sensor, one could be timed, one could be cool in the afternoon, warm in the evening. You can also save energy. You can switch off the lights by the window, have them half on halfway into the office, or full on when you're in the centre of the office where it may be darker. You're not getting the natural light. There's cable designed for this, so you can run control and mains voltage cable together. You can get a 5 or 6 core cable. It's an open protocol, so any manufacturer can design and build components, but it's consistent because there's a certification process, and being digital, it gives you very accurate control. So that's just a quick overview of DALI. Anyway, that's that for this one. I hope it's been of some interest, and thanks for watching.